Hello students, welcome to Power Tutorials. So let's start with today's live session. Sorry I started a little late today, but from next time, whichever time I have scheduled, I will try to continue with the same timing. So today in this session we're going to cover 20 questions, that is previous year questions of probability chapter, and we're going to start with 2025 paper solutions. So I have checked for all the sets and I have found around 20 questions which have been coming from probability chapter. So today we're going to cover those 20 questions. Okay, so I have compared with all the sets and I have found that from 2025 paper, the weightage from the probability chapter is 4 marks. Okay, so these 4 marks are distributed in such way that it can be 2 MCQs, 1 2 marks question, or 1 MCQ, 1 3 marks question, or 1 4 marks question which is of case study. So I'll write it again. These 4 marks are distributed in 3 ways. It can be 2 MCQ questions, 1 2 marks, 1 MCQ, 1 3 marks, as well as 1 4 marks question which is case study. Okay, so it's not like it will get only 2 marks, you will get only 1 mark, you will get only 3 marks. So it depends on how many which type of questions you might get in the board exam. Okay, so let's continue the same. So let's see the first question for probability chapter. So before going to the questions, I will explain small concept. We have this chapter is very easy, one of the easiest chapter I can see. And what is the main important topic from this chapter I will discuss in the short within 1 minute. I will just continue and then we'll continue with the questions. So P of any event is nothing but win by or else winning cases by total cases, probability of not event. Probability of not event is very easy, it is 1 minus P of event. Okay, then we have the range of probability is always between 0 to 1. This is important. Okay, so I think yes, these are the main concepts from this chapter, which is probability of any event is nothing but the total number of winning cases by total number of total cases. Probability of losing an event or the complementary is nothing but 1 minus P of E, and the probability of any event lies between 0 to 1. Okay, so only these concepts are important from this chapter. Using this, if you understand the question, you can solve any question very easily. And these are the questions which can save a lot of time from your board exam, because these can be solved very fast and the other time we can use for the other questions. Okay, so let's start the questions. Just a minute, I'll just keep the tags required for this chapter. Okay, so let's start with the first one. A card is selected at random from a deck of 52 playing cards. So what is the probability? That is a red face card. Okay, so for this we need to remember the cards concept. So total we have 52 cards. Out of which 2 are, half belong to red cards and half belong to black cards. So the red cards are heart and diamond. Heart and diamond are red cards, whereas spade and club are black cards. Okay, among this other cards, all the hard cards starts from A and then 2 and so on, and then till 10, and then we have Jack, Queen and King. Okay, this repeats for everything. Like here also starts from A and so on. 10, Jack, Queen, King. Again A, 2 and so on. 10, Jack, Queen, King. A, 2 and so on. 10, Jack, Queen, King. Okay, so these are called face cards as well, because they have face on those cards. Let's see for this question. What is the question? 50 cards, okay, probability that is a red face card. So red face means we have here 1, 2, 3, here also 1, 2, 3. The total red face cards we have 6 cards. So the answer is 6 by 52. And if you divide by 2, you will get 3 by 26. D is the right answer. And this concept is very important for cards question. Just remember this flow diagram or the architecture, then you can solve any question. Okay, let's move to the next one. Assessment reason question. The probability of selecting a number at random from the number 1 to 20 is 1. So the answer is false. Why? Because this answer should be 1 by 20. Okay, probability of any event P of E when E is called the sure set. Yes, this is true. So A is false, R is true. So the answer is D. Okay, let's move to the next one. 2 dice are thrown at the same time. Okay, we have 2 dice. Determine the probability that the difference of the numbers on the dice is 2. Okay. So the difference, so dice total how many are answers? It can be 1, 2, 3, 4, 5, 6. Here also again 1, 2, 3, 4, 5, 6. So I have to take two numbers such that the difference is 2. So the cases can be 1, 3, 3, 1, 2, 4, 4, 2, 3, 5, 5, 2, and then 4, 6 and 6, 4. So here the difference is 2, difference is 2, difference is 2, difference is 2, difference is 2. Okay, this is 5, 3 here, and then 4, 6, 6, 4. So just check if there any other probability. 1, 4 will become 1, 3 become 2, fine. 1, 4 will become 3, 1, 5 become 4, 1, 5, 6 become 5. So only these are the cases where I can say the difference is 2. So what are total? 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8 by 36, or if I divide by 2, I will get 4 by 18. Again divide by 2, it is 2 by 9. So the final answer is 2 by 9. Okay. Let's move to the next one. Fourth question for today. So let's continue the question. The probability of drawing an even prime number out of numbers from 1 to 30. So we have only one even prime number, which is nothing but 2. Okay, so what are the total numbers? 30. So the answer is 2 by 30. Just a minute. Okay. Number is 2, but now how many number of 2s are present? Only 1 is present. So answer is 1 by 30. Okay, the total number of winning chances is 1, which is nothing but 2. The total numbers are 30. So answer is C. Okay, let's go to the fifth question. In a cricket match, a batsman hits the boundary 7 times out of 42 balls he plays. Okay, fine. The the probability is not hitting a boundary. So this question is related to the one which I told you, the complementary event. So complementary event is 1 minus p of that event. So here they are asking not hitting a boundary, so 1 minus p of hitting a boundary. Okay, so 1 minus p of hitting a boundary is how much? 7 times out of 42. So this is 1 minus 7 1 7 6 42. 1 minus 1 by 6 is nothing but 5 by 6. So 5 by 6 is the answer, which is C. Always remember, whenever there is a question not is mentioned, you have to use p of complementary event. So complementary event is nothing but 1 minus p of that event. So p of the event is 1 minus, in this case it is hitting a boundaries out of total cases. So let's move to the next one, 6th question. So Rahul is a lucky charm for his cricket team. He has a glass of jars with numbers 10 to 74. Okay, before each match he draws a card from the jar. If the card bears an even number, the team wins. If the number is even and divisible by 5, they win by big margin. If the number is odd and less than 30, they win by small margin. If the number is prime number between 50 to 74, they lose. Okay, so we have a cricket team such that we have one lucky charm Rahul. So क्या कहते हैं कि जब भी ये थोड़ा सा नंबर निकालेंगे उस तरफ से लकी चार्म, मतलब अगर वो 10 to 74 टोटल नंबर्स हैं और इस चार से अगर वो इवन नंबर निकालेंगे तो वो टीम विन होंगी, और वो इवन नंबर और डिविजिबल बाय 5 होंगे तो विनिंग होंगे पर बहुत बड़ा मार्जिन से विन होगा, और वो नंबर ऑड और लेस देन 30 होगा तो विन बाय स्मॉल मार्जिन होगा. अगर वो 50 से 74 वाला प्राइम नंबर निकलेगा तो वो लूज हो जाएगा. ठीक है, तो अब चलेंगे क्वेश्चन के बारे में. So let's see the first question. What is the probability that Rahul draws a card with even number? So the numbers we have are 10 to 74. 10 to 74. So the probability of getting a card with even number. So total number of cards are 65. Total cards are 65. Why? Because from 11 to 74 is 64 plus 10. So 11 to 74 is 64 plus 1, which is a 10. So hence the total number of cards are 65. Even number cards will be 33. Why? Because from 11 to 74 we have 64, so 32 even cards, and 10 is again even, so total even cards are 33. So probably Rahul draws an even card. For even card is 33 by 65. Let's move to the next question. 8th question for today. What is the probability that Rahul draws a card with a prime number between 50 to 74? So let's check one by one and figure out whether it has any factors or not, because as per the prime number logic it should have only one itself as a factors, it should not have any other factors. Okay, so look, we can exclude all the even numbers because all the even numbers are divisible by 2. So I'll just note all the odd numbers and then we'll exclude from those odd numbers. We have 51, 53, 55, 57, 59, 61, 63, 65, 67, 69, 71, 73. Okay, among this let's remove 55, 65 because those are divisible by 5, which are divisible by 3. This is divisible by 3, this is divisible by 3, this is divisible by 3, this is divisible by 3. Okay, so we have left 53, 53, 59, 61, 67, 71 and 73. Let's check whether those are divisible by any other number. Starts from 2, 3 will not happen, 4 will not happen, 5 will not happen, 6 will not happen, 7, 8 is 57 will not happen, 8 will not happen, 9 will not happen, 10, 11 is not done, 12, 13, 14, 15, 16, 17, no, it will not divisible by any number. So 53 is a prime number, 59, 59 also I don't think it is divisible by any number. Yes, 59 is also prime. 61, 13, 7, no, 12 table will not, 11, 12, 13, 14, 15 will not happen, 16, 17, 3 is 51. Okay, 17 also will not happen, 61 is also prime. 67, 67, no, 67 is also prime. 71, it is also divisible, not divisible by any number. What about 73, 3, 4, 5, 6, 7, 8, 9, 10, 11? This also not divisible by any number, since all these are prime numbers. So prime numbers are logic simple, just remove even numbers first and then remove 5 numbers and then check for 3. So mostly from there you can get all the prime numbers. So what are the total number of prime numbers here? 1, 2, 3, 4, 5, 6. 6 are the total prime numbers. So the probability is 6 by total numbers 50 to 74. So it is 50 to 74. Okay, till from 51 it is 24. 24 plus 1 is 25. So answer is 6 by 25. Let's move to the 9th question, or 8 optional B. So that's why I haven't mentioned as a question number. Let's see the question now. What is the probability that Rahul draws a card with an even number divisible by 5 from 10 to 74? So even number divisible by 5, the question is very easy, because the only numbers which are divisible by 2 and 5 are multiples of 10. So which are simple: 10, 20, 30, 40, 50, 60 and 70. So which are total cases 7. So I mean winning cases 7. So the probability is simple, which is 7 by 65. Okay, is it clear? Let's move to the 9th question. A dice is thrown once. Okay, we have only like 1, 2, 3, 4, 5. Dice is thrown once. The probability of getting a number which is not a factor of 36. So what are the numbers on dice which are 1, 2, 3, 4, 5 and 6, which are not a factor of 36? 1 is a factor of 36, 2 is a factor of 36, 3 is a factor of 36, 4, 5. So only number which is not a factor of 36 is 5. So simple, it is 1 by 6. Because they clearly mention not a factor of 36. Not a factor of 36 is only 5 is not a factor of 36. Hence the answer is 1 by total cases, which is 6. Okay, next move to the 10th one. So whoever joining recently, thanks for joining. So in this video I am going to cover 20 previous year questions from probability chapter. So which are from 2025 set. From all the sets I have compared and I have found around 20 questions which are from probability chapter. So I am going to explain about the solutions from these 20 questions. Okay, till now 9 questions are done. I am going to the 10th one. The probability of guessing the correct answer of a certain test series is, okay, so P of E, they have mentioned the probability value is x by 12. The probability of not guessing the correct answer is 5 by 6. So simply P of complementary event is 5 by 6. So what is complementary event? I told you P of complementary for any event is nothing but 1 minus P of E. So it is 1 minus x by 12. Okay, from this I can say if I move x bar to the left side and 5 by 6 to the other side, I will get x by 12 is equal to 1 minus 5 by 6. So 1 minus 5 by 6 is 1 by 6. 6 1 6 2's. So I can say the x value is 2. Always remember the probability of not event is nothing but 1 minus p of that event. So here not event is 5 by 6. P of the event they have mentioned as x by 12. So 1 minus 5 by 6 is nothing but x by 12. Hence x value is 2. Clear? Let's move to the next one. 11th question. 3 unbiased counts are tossed simultaneously, finding the probability of getting. Okay, so this is a 3 marks question and each A, B, C carries 1 mark each. Let's solve all these questions. But before that, 3 unbiased counts. So let's get all the cases for unbiased counts, which are TTT means all true. Okay, here it is all tails. TTH, THT, THH, THT. Wait, it's already done. HHH, HHT, HTH, and HHH. Okay, so this is important, and compared to 3 coins are tossed, so all these 8 are the possibilities. Okay, so among this, let's see what is the question. 3 unbiased coins at least exactly 2 tails. So exactly 2 tails we have TTH exactly 2. Okay, THT. Anything else? We can see exactly only 2 tails. There is no other tail. Okay, only 2 cases. Exactly 2. So we have only 2 possibilities. So here the probability is nothing but 2, but total cases are 8. Okay, let's see the B part. At least 1 head. At least means it can have 1 head, 2 head, or 3 heads. Okay, so 1 head I will write first. TTH, THT. Okay, these are 1 heads. Next 2 heads. THH, HHT, HTH. Okay, this belongs to 2 heads, and 3 heads we have only one, which is HHH. So the total cases are 1, 2 plus 3. 1, 2, 3, 2, 3, 4, 5, 6. The total cases are 6. Hence the B answer is 6 by 8 or 3 by 4. Okay, and repeating the B part. So here they are asking at least 1 head. So you have to consider 1 head, you have to consider 2 heads, and also we have to consider 3 heads. Okay, so C part I will do it again. So C part they are saying at most 2 heads. At most means we can have at least 0, 1 or 2 also. Okay, that means at most means maximum it can have 2 heads. So what is so we have to consider at most is minimum 0, maximum is 2. We have to consider 0 heads, 1 head, and 2 heads. All 3 have to consider. Okay, so 0 heads are TTT, 1 head is THT, TTH, HTT. So this belongs to 1 head, and 2 heads category HHT, THH, HTH. This belongs to 2 heads category. So total how many I have? 1, 2, 3, 4, 5, 6, 7. So it belongs, the answer is 7 by 8. And here it cases is at least 1 head. So it has to have 1 head, it has to have 2 heads, and it has to have 3 heads. Okay, wait, and this question I think we missed one more. THT is fine. THH we have 2, HHH we have 3, 1, 2, 3, 4, 5, 6, 7, just one, HTH, HHT. Okay, I think I wrote somewhere wrong. 1, 2, 3, 4, 5, 6, 7, 8. HTH. Okay, HTT is missing. HTT, and we have one HTT as well in the first case. Okay, so this belongs to single head, these are two heads, and this is single head. So this question, the answer is also 7 by 8, not 6 by 8. The B answer is also 7 by 8. Okay, so we have second answer is also 7 by 8, and third is also, C part is also 7 by 8. Okay, let's move to the 12th question. The number of red balls in a bag is 10 more than the number of black balls. Okay, so red balls is x more than black balls because we are considering the black balls as x. Okay, what is the probability of drawing a red ball at random from the bag is 3 by, red ball probability is 3 by 5. So P of R is 3 by 5. So this I can say it as nothing but 10 plus x. Winning cases of red, but total cases it becomes 10 plus x because we have black balls as well, and black balls I am considering it as x. So this I can say it is nothing but 3 by 5 is equal to 10 plus x by 10 plus 2x. Now let's cross multiply. So this becomes 30 plus 6x is equal to 50 plus 5x. So let's move 5x to the other side, becomes 6x minus 5x, which is x is equal to 50 minus 30, which is 20. So the black balls are 20 and red balls are 10 plus 20, which is nothing but 30. Let's see what they are asking. Total number of balls in the bag, which is 30 plus 20, which is 50. Okay, let's move to the 13th. A pair of dice is thrown. We have two dice. The probability that the sum of numbers appearing on the top faces is at most 10. Okay, so at most 10 means it can have minimum value, it can have anything, and the maximum value can be only be 10. Okay, and for this question we can do in different way. 1 minus p of probability greater than 10 if I do, and if I just subtract I will get this answer faster instead of solving each and everything. Okay, so p of greater than 10 cases we'll write here first. Greater than 10 it can be 5, 6 and 6, 5. Any other case I will get it will be less than 10. Okay, so hence 1 minus p of greater than 10, which is 1 minus p of 2 by 36. So which is 34 by 36. So 12 to 18s. Okay, I think I am missing one more. You have 6, 6 also here. So the three cases which are not the probability. So 1 minus 3 by 36. So which is nothing but 1 minus 1 by 12, which is 11 by 12. Hence D is the right answer. So if you solve in normal method it will take lot of time. So always remember for this type of questions just think in opposite way, because complementary is we have one concept where P of complementary event is 1 minus P of that event. Okay, let's move to the 14th. Two friends Anil and Ashraf were born in December month in the year 2010. Find the probability that they share the same date of birth. So December total number of days are 31. So the winning case can be only 1 out of 31. So the first answer is 1 by 31. What about second? They have different date of birth. So P of not event. So not event is 1 minus P of event. So which is 1 minus 1 by 31. So which is 30 by 31. because total number of cases for December event is 31, because total number of days are 31. Okay, let's move to the 15th question. So 6 more questions for today. A bag contains red balls and black balls in ratio 3/7. A ball is drawn at random. The probability that the ball so drawn is black in color. So this question is easy. So simply they're saying red balls are 3 out of, okay, ratio they have provided. They have mentioned the values. So the ratio is 3/7. Okay, so just assume that the ratio is like common multiplier is just x. So let r is equal to 3x and black balls is equal to 7x. Okay, so now we will see what is the probability that round is black in color. So P of black is equal to winning cases of black by total cases, which is 3x plus 7x, which is 7/10, which is 0.7. Okay, so always remember, if it is ratio, don't simply write 3/7 because it's not total cases. So always the probability is winning by total cases. Okay, let's move to the 16th. So what is 16th question? A probability of getting a composite number greater than 3 on throwing a dice. So if you throw a dice, what are the total cases? 1, 2, 3, 4, 5, 6. Greater than 3, we have this many. So what are throwing a dice? Getting a composite number. So what are the composite numbers? We have 4 and 6. So the answer is 2/6. Or if you divide by 2, I will get 1/3. Okay, next move to the 17th question. So as I mentioned, the probability chapter is easy because you can see between 1 to 2 minutes and able to solve each question. So that's why whenever there is a probability questions, just try to answer them fast, at the same time answer them correct, so that you can utilize the other time for the rest of the questions, like because triangles, circles and surfaces and volumes, those questions will take more time to solve, whereas few chapters like arithmetic progression, probability and even statistics, this take very less time. So always first focus on these questions faster, so that the other time can be utilized for the other rest of the questions. Let's do 17th question. While shuffling a pack of 52 cards, if one card is randomly dropped, find the probability that the dropped card. So simply they're saying one card is randomly picked. So same way, if it is dropped or randomly, both are same. So one card is randomly picked or one card is randomly dropped. They're asking regarding that card whether it is not a face card. So total face cards, I already told you in the previous question, the total we have 12 face cards. Okay, so the 12 face cards and saying it is not a face card, so simply 1 minus P of face card. So it is simple, 1 minus face card. So I told you it is total 12 will be present out of 52. So it is 1 minus 4 double. If I divide 4 3s are 12, 4 1s 4 3s are 12, it is 1 minus 3/13. So which is 13 minus 3/13, which is 10/30. Okay, second is a black king. So how many black cards are present? Black cards are 2 sets out of 52. 26 are black colors, and out of which kings they are asking, so only one king. So total 2 black kings will be present. So what is a black king probability? Which is 2 out of 52 or 1/26. Okay, so these things I have explained clearly at the starting. So I'll just give a brief about that topic again. So total 52 cards are present, out of which 2 are red. 4 sets total, 2 sets are red and 2 sets are black. So 26 are red, out of which we have 2 kings. 26 are black, out of which we have 2 kings. So total 2 black kings they are asking about. So black kings are total, we have only 2. So 2 out of 52 is a probability for this question. Okay, hence it is 1/26. Let's move to 18th question. 3 more questions for today. 2 coins are tossed simultaneously, probability of getting at least one head. So 2 coins, it is easy, TT, TH, HT, HH. Okay, let's see what they are asking. At least one head. So these 3 are cases which have at least one head. So the answer is 3 by total probability 4. See, within 10 seconds I solve this question. Okay, next 19th event. E1 getting a number less than 3 and even E2 getting a number greater than 3, less than 3 and even greater than 3 are complementary integers. The answer is false. Why? Because less than 3 is present, greater than 3 is present, but equal to 3 is missing. Okay, equal to 3, if it is say something like less than or equal to 3 and greater than 3, then this is correct. Or less than, greater than 3 and less than or equal to 3, then it is correct. But here equal to 3 is missing, so hence this statement is false. Whereas 2 events complementary events and P of, yes, this is true, but A is false. Okay, A is false, R is true, the answer is D. So this is tricky question I can say, because every time they less than and greater than, people might assume it is same, but it is not same, because equal to case should also be there, not only less than and greater than. Okay, let's move to the 20th. Time is okay, we have 90th also done. Okay, last question for today. The number of red balls in a bag is 3 more than the number of black balls in bag. Okay, so for this, as this is a 2 marks question, I will write in detail. Let us assume black balls as x, then red balls is equal to 3 more than, so it is 3 plus x. Okay, if the probability of drawing a red ball at random from the given, so red ball I have mentioned, it is P of red ball is 12 by 23, so 3 plus x by 3 plus x plus x. Why? Because winning by total cases. Okay, hence this becomes 12 by 23 is equal to 3 plus x by 3 plus 2x. Let's cross multiply. This becomes 12 into 3 plus 2x is equal to 23 into 3 plus x. Okay, so this becomes 12 3 is a 36 plus 12 2 is a 24, x is equal to 3 3 is 9, 3 2 is a 69 plus 23x. So if I move 23 minus 24 minus 23 becomes x is equal to 69 minus 36. So the x values, 9 minus 6 is 3, 6 minus 3 is 3. So the x value is 33, which is black balls. Black are 33 and red are plus 3, so which is 36. So what they are asking the question? The total number of balls in given bag. So total number of balls, total number is equal to 33 plus 36, which is 16. So 16 is final answer. Okay, so in this way all the questions of probability chapter are done. So mostly today or tomorrow I'll have another session. In the next video tomorrow, if possible, I'll do it, or else recorded session if possible I'll do it. So next question I will try to cover quadratic equations, PYQS, and I'll try to cover at least 15 plus questions. Okay, and this time I'll try to make it around 9 PM tomorrow. Okay, so thanks for watching. Let's meet again tomorrow at 9 PM with quadratic equation PYQs. Thank you.